James and Christina want to create a sculpture made from cubes of ice. The shape of the structure is shown. So the figure is made up of identical cubes of ice. Each cube of ice has a length of 1 unit. What's the volume? Okay. Basically, this question, this is a great one to do with younger folks, with kids in the elementary school, is to build three-dimensional shapes out of cubes. They have cubes that connect and they make three-dimensional objects. And or you could just use, like they said, sugar cubes or something like that. In the old days, you'd use sugar cubes, but now we have nice little plastic blocks, manipulatives for the classroom that you can use and build three-dimensional shapes. And so what they're going to have us do is, first off, answer the volume and the surface area for the whole three-dimensional shape. And then they're going to say, now break it all apart, decompose it into individual cubes, break them all apart, and then recalculate the volume and the surface area after it's all broken apart. That's what this question is all about. Volume and surface area when it's together, and then volume and surface area when it's all broken apart into individual cubes. How's that going to change? Well, let's start with the volume. To find the volume, we all have different shapes here. What I would suggest is just counting. I think that's about the easiest thing to do. What do I mean? I mean literally come in here and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. There we go. And then that is how many layers of that? We have we have 1, 2, 3, 4 layers. So it's 27 times 4. You tracking with me there? And so that is 100, 108. So I just counted how many cubes were in the first layer, 27. And then I multiplied by 4 because there's 4 layers of 27, at least in my picture. So that's, I think, a nice, easy way to get the total volume of that object. Count the first layer, 27 cubes in the first layer times 4 layers deep. Now, next question is they want us to come up with the surface area. So that, remember what surface area is? That's all the surfaces. Like if you wanted to paint the thing, you want to paint every surface, right? How many little squares would you have to paint? How many squares on the surface? Well, do you realize, let's break it into sides. There's actually 6 sides. There's the front and the back, the right and the left, the top and the bottom. It's surface area is pretty hard. So first off, right here on the front, there are 27, right? Let's just take it here. I'm going to put it up here. Surface area. And I'm going to say, well, on the front there's 27. And then on the back, there's going to be the same thing, right? 27 on the front. Here's the back. The back, we can't see the back, but it's identical to the front. So the front and the back is going to have 27 each. Now, let's count the, let's do the top. Let me come up here to the top. I'm going to do the top. So how many on the top? Well, I'm just going to count them. 1, 2, 3. Now I'm only counting tops. Only going to paint the tops of these blocks. 8, 9, 10, 11, 12, 13. See, I'm skipping that right side there because I'm not doing these. Why? Because this is the right side. I'm going to do the right side in a minute. But right now I'm just doing the top of all the blocks. Just the tops. Right? This is top right now. So down here, jump down here. 17, 18, 19, 20, 21, 22, 23, 24. So on the tops, there's 24 top surfaces. Trying to get all the surfaces, all the squares that we would have to paint. There's 24 squares on the top. What about the bottom? Squeeze this in here. What about the bottom? It's going to be the same, isn't it? Down here in the bottom. And in fact, you know what? It would have been easier to start with that. Let me show you. You're probably already thinking that. So you're doing it better than I'm doing it. Yeah, this is already, what is this? 6 this way and 4 this way. This is the bottom, right? It's the same as the top. And that would have been quicker. It's 4 by 6 and the top has to be the same. What would have saved me time? All right, now, all we have left is the right and the left. Let's do it. So the right, let's get the right, let's count the rights. 1, 2, so I'm doing the right sides, right surfaces of the cubes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. There's 24 rights. What do you think about the left? It's going to be the same. And you know what? It would have been quicker to start with the left, wouldn't it? Y'all seeing that? Oops. Let me show it clearly. There and there, right? This is what? 4 this way and 6 this way. This is the left side. 4 by 6. It's clearly 24. So it would have been quicker to just do the left and then say, well, the right is the same, wouldn't it? That would have saved time. So really, I should have done this problem more quickly. You could just count the front, the back's the same, and then count the bottom, just 4 by 6, and the top's got to be the same. And then do the left, which is 4 by 6, and the right's got to be the same. Would have been quicker, but it's good. We learned through this. So now just add them all up, right? Total SA, total surface area, whatever those are, add it up. I'm getting 150. Is that right? Yeah, 150. So 150 square units make up the whole surface. You want to paint this thing, the front, the back, top, bottom, right, left. Got to paint every square. There's 150 squares you would have to paint in this 3-dimensional shape. Now, having done all that, here comes the big question. Suppose the solid, would be a little scribbly there, let's try that again. Suppose the solid is decomposed into individual cubes. That's weird. Box here. There we go. So that's kind of weird. I'll leave it like that. Suppose the solid is decomposed into individuals. You're going to break it apart now. So now we're going to take this 3D shape and break it all apart. This is a great exercise to do with elementary school kids, is to teach them this difference. Now they're going to ask us, okay, what's the volume now? Well, what do you think? What's the total volume? Well, that's not going to change. That's still 108, just like the volume was before. There's no change in volume, right? Remember, volume is how much space inside. Like if you wanted to fill it up with water or whatever. How much, if there's sugar cubes, how much total sugar? Well, it doesn't change, right? The total amount of sugar as a 3-dimensional shape or decomposed into individual cubes, it's still the same total volume of sugar, but the surface area will dramatically change. What am I talking about? Well, what's going to happen when we break it all apart into individual cubes? How's the surface area going to change? Well, if you break these all apart, all these little cubes, break them all off, and now you want total surface area, like you want to paint all the cubes. Well, every cube, let's draw one. Let's try to be really clear here and draw one of the cubes if I can. Let's see. I have a drawing tool thing here. I want to make it a square, and that was not the best. Good enough. So we have a cube, right? How many sides does that have? 6, right? 6 sides. Each cube has 6 sides. So if you're going to decompose them into individual cubes and you want to know the total surface area of all the cubes, well, it's going to be the number of cubes times 6, isn't it? Does that make sense? If you're going to break it all apart and you want to know how many surfaces, well, every cube has 6 squares around it, 6 sides. So you just got to take the total number of cubes and multiply by 6. What's the total number of cubes? Well, that's the 108. 108 is how many cubes, right? It was 27 on the front layer times 4 times 6. And multiply that by 6. There's 108 total cubes. Multiply by 6 surfaces, 6 sides on each cube. 648. So the total surface area changes dramatically when we break apart the three-dimensional shape into, decompose it into individual cubes. We get a lot more surface area. Why? Because a bunch of the surfaces were covered up because they were touching. We didn't have to paint them, right? In the three-dimensional shape, a bunch of the surfaces were touching each other, so we didn't have to paint them. They were inside. They weren't outside, so we didn't have to paint them. But if you break it all apart, well, then you got to paint all 6 sides for every cube. Total number of cubes times 6. That changes the surface area a lot. The volume doesn't change at all. So that's a good exercise for kids to see the difference between volume and surface area, three-dimensional shapes, and decomposing into individual shapes. There we go.